Hello students, this is a video about the Bodhee Prep topic tests on QA. Now these topic tests have been designed so that they help you evaluate your test readiness. So once you have done basic concepts of a topic, you are advised to take these tests. Once you take a test, there is a video for each test. The video would be an analysis of the test and the solutions as to what you could have done with the test, what would be a good attempt, the kind of time that should be put in. Also, on the Bodhee Prep app, there are more than 200 such topic tests available across 40 topics of QA. The link of the app is in the description of this video. Do download the app and make use of these tests that we prepared for you. This video is about the chapter number system. The topic for this video is properties of numbers, and this is test number 5 from this topic. Overall, the test was a moderate level of difficulty, and about 5 to 6 questions would be a good attempt. Net correct would give you a 95 odd percentile, and attempt time would be around 20 to 25 minutes. There were, I think, a couple of questions where cases will be formed, so that kind of drives up the overall attempt time. But the questions which are to be attempted to get your marks would not be very time consuming. If we do look at the questions, this is the first question. A plus 1 by B plus 1 by C plus 1 by D and so on is equal to a cube root of 2. Now, cube root of 2 is in value around 1.26 something. This is approximately 1.26 something. So basically what it says is A plus 1 by B plus some value. So I'm taking this entire thing as X. A plus 1 by B plus X, because you have to find the value of B, is equal to 1.26. Or this can be written as 1 plus 0.26. From here, I can say that A will take the value of 1 because 1 upon B plus X will take the value of 0.26. So 1 upon B plus X is equal to 0.26. 0.26, now we have to understand, lies between 0.25 and 0.33. Why 0.25 and 0.33? Because the fraction value of these numbers is known. And therefore, we can say that 1 by 4 is less than 1 by B plus X is less than 1 by 3. And therefore, I can say that if we compare these two, B plus X has to be a value between 4 and 3. So B plus X has to be greater than 3, but less than 4, taking the reciprocal, which means B plus X is 3 point something. Hence, what is the value of B? The value of B will come out, because this X will be a decimal value. So value of B will come out to 3. Now, as far as I am concerned, in terms of examination, for me, this is a very difficult question. Though it is fractions, but unless you know exactly what to do, figuring out would not be very easy, and therefore a difficult question will easily take up time. Even if you know, 2 minutes is 2.5 minutes will be required to solve this question. N is a 5-digit perfect square whose unit digit is same as the tens digit. So the first 3 digits and then the last 2 units and tens, these are same. So the values that they can take are 0, 0, 1, 1, 2, 2, 3, 3, and so on. If I list down all the cases of 5-digit numbers having the same unit and the tens digit, these will be the total cases possible. There are 3 numbers ahead of each of these: 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 7, 7, 8, 8, 9, 9. Now, since these are squares, none of the squares end in 2, 3, 7, and 8. So this is not possible. 0, 0 is possible. What about 1, 1? Again, if I multiply a number which has a digit A and then 1 with itself, the last digit will be 1. Here we will get 1 into A plus or A. From here we'll get A, and therefore the tens digit has to be 2A, which cannot be odd. So a square cannot end in 1 and 1. If I look at 5, a similar thing happens. A5, A5, 5 5 is 25, carry forward to 5A plus 2 is what we'll get here, and here we'll get 5A, and therefore the tens digit place has to be 10A plus 2, which will again be even, cannot be 5 5. If we look at 9, 9, a similar thing happens. A9 and A9 here multiplying with itself. 9 nines are 81. 1 carry forward 8. This will give us 9A plus 8. And then a 9A here. So 18A plus 8. So the 10th digit has to be an even number, cannot be. Sorry, we're looking at number ending in 9. For 9, we look at multiply numbers ending in 3 and 7. A3 into A3. 3 threes are 9, 3A, 3A, and therefore 6A, 9. Unit digit is even. Similarly, if you look at A7, the same similar thing happens. So the square cannot end in 9, 9 as well. We have 0, 0 ending, 4, 4 ending, 6, 6 ending. Is 6, 6 possible? Again, to get a 6 in the end, we would have to multiply A4 and A4, where A is a digit. 4 4s are 16, carry forward 1. 4 A is a 4A plus 1. Here also we'll get 4A. So the 10th digit will be 8A plus 1, which is odd, and then 6. Cannot have 6 in the end. Similarly, if we multiply A6 and A6, 6 6 and 36, carry forward 3, 6A plus 3, and then a 6A here. So 12A plus 3. 12A plus 3 is odd, cannot be 6. So cannot end in 6 and 6. Now, if I do not know this fact, I will have to check for all the numbers. If I know, then I'll know that a square having the last two digits same can only end in 0, 0 and 4, 4. So that is where I start my solution from. Case 1, where the last two digits are 0, 0. What can be the first three digits? This is a square, so the first three digits have to be square. The first square, which has three digits, is 100. So this becomes, the square root of this becomes 100. The last three digit square is for 31, which is 961. The square root for this becomes 310. So basically, if you look at this, we are looking for all squares from 10 to 31. How many numbers will be there? From 10 to 31, there will be 22 numbers. 31 minus 10 plus 1. So 22 cases of the first kind. Case 2, then where the number is ending in 44. Now, when does this happen? Again, if I do not know, I will make a case for it and I'll see. If I multiply A2 and A2, I'll get a 2 2s are 4 in the end. 2A, 2A. So 4A plus 4. If we want A to be 4, A could have a value of 1 or A could have a value of 6. So numbers ending in 12 and 62, when squared, will end up in 44. Similarly, A8 and A8. 8 8 is 64, 4. Carry forward 6, 8A plus 6. And here we'll get 8A, therefore 16A plus 6 and 4. If we want this to be 4, this has to be 8. And this can be 8 if A is 8. 8 6 is 48 plus 6 becomes 4. Happens at 8. So the generic rule that we end up getting is, will also happen at 3. So if a number ends in 38 or 88, even then we get the last two digits as 44. Again, I did not know the rule, so I had to calculate. The generic rule for this is 50n plus minus 12. Any number which is of the form 50n plus 12 or 50n minus 12, this will end in 44. The square of these numbers will end in 44. Now, if we look at the numbers having squares which are 5-digit numbers, of course, the smallest number is 100, which will have a 5-digit square. The largest number will be somewhere around 310. So we can check for 312, 313 to find this out. To make my calculation easy, I'll start with 315. So 315 into 315 will be 5 5s are 25 in the end. 31 into 32, 31 into 32 is 961 plus 31, which will be 99225. The square of 315 is 99225. Clearly, this will be very close to the last 5-digit square, or the last 5-digit square will come out to 316 square. This will be the last 5-digit square, because we can add 315 and 316 to it. It will be a 5-digit number. So this is my range of numbers. Now, Here I will look at numbers which are in the form of 50n plus 12, 50n minus 12. So the first number here will be 50n, where n is 2, so 112. When n is 3, 138. When n is 3, 150 plus 12, 162. So basically 112, when we are adding 12, 112, 162, 212 and 312. 100 plus 12, 150 plus 12, 200 plus 12, 250 plus 12, and then 300 plus 12. When we are subtracting 12, 100 minus 12 will not work. So 150 minus 12, 200 minus 12, 250 minus 12, 300 minus 12. 350 minus 12 will not work. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 cases here. 22 cases here, 9 cases here, total of 31. Since I made all the cases, the attempt time of this question becomes really high. Ideally, we would want to be in a position where we know that these are the two cases we are looking for, and the common case for 44 is this. Then the counting becomes a lot more easier. And in that case, if we know these two things, I'll say this is a moderate question which could have been attempted in about 2.5 minutes. How many times does the digit 6 appear in the first 1,000 natural numbers? So basically, we're writing numbers from 1 to 1,000. 1,000 does not have 6. Now, one way of counting this is we count 6 in the 1-digit numbers, 2-digit numbers, 3-digit numbers, and so on. Or what we can do is we look at both ways. So my preferable way will be I express all the numbers as 3-digit numbers, and I start counting from 001, 002, and I look at 999. 1,000 does not have a 6, we already know. So all the 6s that have to appear will appear here. How many numbers are these? Or rather, let us start from 000 and not 001. Now, if we look at these cases, these are 1,000 numbers from 0 to 999. Each number is expressed as 3 digits. So total 3,000 digits will be written. 1,000 numbers, each number has a 3-digit number, 3,000 digits are written. And this will complete one full cycle. That is, all numbers will equally be represented. Numbers from 0 to 9 have been used. So 10 numbers have been used. So each number will appear 1/10 of 3,000. That is 300 times, and that becomes the answer for 6 as well. Just making a basic shift, we are able to figure out 1,000 numbers from 0 to 999. 0 and 1,000 do not have a 6, so making that shift will not change my answer. Therefore, I'm making the shift. Each number expresses the 3-digit number, so 3,000 digits required, and each digit used equally. 10 digits are there, so 300 times each digit will be used. So 6 appears 300 times. This is one way of doing the question. Makes the question a lot easy. Can be easily done within a minute. Otherwise, we can count. Now, we know that every number except 0 appears 20 times in the ones and the tens place from 1 in 100 natural numbers. So 1 to 100, 6 will appear 20 times in ones and tens place. 101 to 200, again 20 times. 201 to 300, again 20 times. And so on till 901 to 1,000. Again 20 times. So 1, 2, 3, there will be 10 such cases: 100, 200, 300, 400, 500, 600, 700, 800, 900, 1,000. So 200 times in the ones and the tens place, plus 600 to 699. 6 will appear 100 times in the hundreds place, so a total of 300. Even if you count it like this, should not take more than 1.5 odd minutes if we know the pattern in which we have to count. In any case, easy question. If the arithmetic mean of 80 in base 9 and 18 base 16 is 14 base, and find the value of n. Now, the value of 80 in base 9 in decimal system will be 0 plus 9 raised to power 1 into 8. This will have the place value of 9 raised to power 0. This will have a place value of 9 raised to power 1. So this becomes 9 into 8 in the decimal system. 80 into 16 will have a place value of 0 into 16 raised to power 0 plus 16 raised to power 1 into 8. Sorry. So this will become 16 into 8 in the decimal system. Now the mean of these two numbers will be 9 into 8 plus 16 into 8 by 2, which is nothing but 8 common into 9 plus 16, 25 by 2, which is 100. This is in the decimal system. This is given as 40n. So we can say 100 is equal to, if we convert this into decimal system, we'll get 4 into n plus 0 into n raised to power 0, or 100 is equal to 4n, which will give us the value of n as 25. So the base system here is 25. That becomes the answer. The topic is base system, subtopic, but the question is not very difficult. Could be attempted in about a minute and a half. If x delta y plus 1 is equal to y delta x plus 1, x delta x is 1, x minus y delta x plus y is x delta y. What is the value of 1001 delta 1? It is, again, if we look at the three equations given, the only case where you get a value is this one, and the value is 1. So ideally, the answer has to reach to 1 in some way. Now, if I try to look at the three identities, the only identity that seems applicable is this one, because here x minus y will be a value less than x plus y, whereas here we have a value which is greater on the left hand side, smaller on the right hand side. So 1001 delta 1 I am taking as x delta y plus 1. So here x becomes 1001, y plus 1 becomes 1, which means y is 0. So the value of this will be y, which is 0, delta x plus 1, which will become 1002. Now this is the same as, this can be used like the third identity. 1000 to half of 1002 is 501. So we can write this as 501 minus 501, which is 0, delta 501 plus 501. So this becomes x minus y delta x plus y, the value of which is x delta y. So 501 delta 501, and x delta x is equal to 1. As you can see, the final value comes out to 1. Now, if you know what you are doing, this is just a one-line question. Otherwise, it is very easy to get confused with the signs and the assuming, we tend to assume associative property over this sign and make mistakes. But in any case, I think 2.5 minutes on the upper side should be good enough to do this question. A moderate to difficult level of question answer, because the chances of confusion are very high. A book has exactly 300 pages numbered 1 through 300. So the first page will be numbered 1 on one side, 2 on the other side. Second will be numbered 3 on one side, 4 on the other side, 5 and 6 on one side and the other side, and so on. Last page will be 299 and 300 on one side, 299 on the other side, 300. Page number, that is a multiple. Okay. If all the pages on which there is a multiple of 4 are torn out, so this page is gone, 7, 8 is gone, and so on. So is 29, 300, that is also gone. What is the total of all the pages on the pages that remain? So the pages that remain will be 1, 2, 5, 6, 7, 8 will go away, 9, 10, 11, 12, 13, 14, and so on. And this will go up to 297, 298. As you can see, there are two types of two different arithmetic progressions with a difference of 4. 1 plus 5 plus 9 plus 13 up to 297. 2 plus 6 plus 10 plus 14 up to 298. Now the number of terms here is, the first term is 1 plus 4 into 0. The last term is 1 plus 297 minus 1 is 296. 296 by 4 will be 728, 71 short of 75. 4 into 74. So there are 75 terms. So the sum of this arithmetic progression will be n by 2 into first term plus last term. The sum of this arithmetic progression will be, the number of terms will be same, n by 2 plus into first term plus last term. This becomes a 75 into 298 by 2. 298 by 2. 149. 149. And here it will be 275 into plus 298, 300. So 75 into 150. Therefore, the total sum will be 75 into 149 plus 150, 149 plus 150, which will be 75 into 299, 299, which will be 75 into 300 minus 1. 75 into 300 will come out to 2250, 22500 minus 75, which will be 22425. And this becomes my required answer. Again, an easy to moderate question. Should be able to do this in 2 minutes. Just adding two arithmetic progressions, all we have to. In how many ways can 2700 be written as a product of 8 distinct integers? Integers means positive, negative, both allowed. So first let us factorize 2700. 2700 is nothing but 27 into 10 into 10. 27 is 3 cube. 10 into 10 is 2 into 5, 2 into 5. And therefore the prime factorization of 2700 will be 3 cube into 2 square into 5 square. Now clearly there are 3 threes, 2 twos and 2 fives. Total number of primes are only 7. We want to express 2700 as a product of 8 distinct integers. So if we separate all of them, we can write 3, 3, 3, 2, 2, 5, 5. This is only 7. We're not reaching 8. So what do? We introduce ones because that will not change the answer. So now we have 8 integers, but they are not distinct. So to make them distinct, what we can do is one of the two we take as negative, the other two we take as positive. One of the 5 we take as negative, the other 5 we take as positive. Similarly, one of the 3 we take negative, the other 3 we take positive. Now, 1, 2, there are this one is already there. There are 1, 2, 3 negative signs. So this product is negative. So we put in a minus 1. Now, if we look at it, minus 1, 3, minus 3, minus 2, 2, minus 5, 5, 1. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 distinct integers. 3 has been used twice, 2 has been used twice, 5 has been used twice. So from this product, 1, 3 is remaining. What do we do with this 3? If we multiply this 3 with minus 3, we will have minus 3 and minus 3 common. If we multiply 3 with this 1, we will have 3 and 3 common. Therefore, 3 remaining can be multiplied by any one of these numbers to get a unique way. For example, if I multiply 3 by 3, I will get minus 1 into 9 into minus 3 into minus 2 into 2 into minus 5 into 5 into 1. This is one way. If we multiply the 3 with minus 3, we will get minus 1 into 3 into minus 9 into minus 2 into 2 into minus 5 into 5 into 1 and so on. So how many ways are there? 3 can be multiplied 1, 2, 3, 4, 5, 6 places to get 6 distinct ways or 6 different ways, and therefore 6 becomes the answer. In terms of level of difficulty, I would say it is a difficult question because there are very high chance of getting confused and losing track somewhere in the middle. 8 distinct integers will take time to build, and therefore, if we are able to get the crack, then about 2.5 minutes to solve this question. 2 to 2.5 minutes to solve this question. If ABC are positive integers such that a minus b plus c, b minus c plus a, c minus a plus b is 15, what is the product of ABC? So each of these terms has to have a value. Suppose we break down 15 as 1, 3 and 5. So a minus b plus c can be written as 1, b minus c plus a can be written as 3, c minus a plus b can be written as 5. If we add all of these three, b minus b cancel, c minus c cancel, minus a cancel. So we'll be left with a plus b plus c is equal to 5 plus 3, 8 plus 1, 9. Now, since they are positive integers and there is a negative value in all of them, these could also have negative values. But for 135, this will be the only case because since the product is positive, at least two values have to be negative. In this case, the sum will be 5 minus 3 minus 1, which is 1. Minus 1, 3 and minus 5 will give us a negative sum of these three values here. 1 minus 3 minus 5 will also give us a negative sum. But a plus b plus c, since a, b and c are positive integers, has to be at least 3. So these three cases are by default neglected or they will not be possible, and the only possible case will be 135. Also, because the terms are cyclic, any of the term could be 135. We will get values for A, B, C, three values, which either of them can take depending on whether we take this as 1, this as 3, this as 5, this as 3, this as 1, this as 5, and so on. Since we have to find the product of ABC, it does not matter which is A, which is B, which is C exactly. Now we try to solve from here. To A plus B plus C, I add A minus B plus C is equal to 1. Adding these two, we get twice of A plus twice of C is equal to 10, which means dividing by 2, A plus C is equal to 5. If A plus C is 5 in this case, 5 minus B is equal to 1, which will give us B as 4. A plus C is 5, 5 minus B is 1. If B is 4, from here we can write A plus C is equal to 9 minus 4, which is 5. And from here we can write C minus A is equal to 5 minus 4, which is 1. Again, adding the two, we get 2C is equal to 6, which means C is equal to 3. Putting the value of C in any of the equations, here we'll get the value of A as 2. So A into B into C is equal to 2 into 3 into 4. But the question does not end there, because another case is possible where A minus B, or may be possible, where A minus B plus C is 1, B minus C plus A is 1, and C minus A plus B is 15. 1 into 1 into 15. So in this case, if we add, we'll get A plus B plus C is equal to 17. A minus B plus C is equal to 1. Adding 2A plus 2C is equal to 18, or A plus C is equal to 9. Since A plus C is 9, we can put that value here. 9 minus B is equal to 1, so B will come out to 8. Putting that value, suppose here we already have A plus C is 9. Putting that value here, we can get C minus A is equal to 15 minus 8, which is 7. Adding 2C is equal to 16, C is equal to 8. Putting that value here, A is equal to 8 minus 1, 1. And therefore, in this case, A into B into C will be 1 into 8 into 8, 64. So what is the product of ABC? Multiple values are possible, therefore cannot be determined. Moderate level of difficulty, very high chances of getting this question wrong, because we'll get one case and we'll get an answer. If we miss the second case, it is a negative marking for us. In a game played by two people, there were initially n matchsticks kept on the table. A move consists of a player removing either one or two matchsticks from the table. The one who takes the last matchstick loses. Players make moves alternately. The player who will make the first move is A. The other player is B. The smallest value of n greater than 5 that ensures a win for A. For B, the person who picks the last stick loses. So when A starts, A will either pick 1 or 2. In the second try, when B comes, B can add a number to this to make the total 3. So what we can do is we can pick 2 in this case or 1 in this case. So 3 matchsticks have been picked. Again, A comes, A will either pick 1 or 2. Correspondingly, B can pick 2 or 1. So in both cases, 6 matchsticks have been picked up. Any combination of these two chances that A and B take, 6 matches would have been picked up by now. And therefore, if there is one matchstick left, that will have to be picked by A. So, in a given question is smallest value of n greater than 5 that ensures B wins. N is the number. So, if there are 7 matchsticks on the table, greater than 5 smallest value, for the first 6 matches, AB will ensure 3. Again, AB will ensure 3. 6 matches are picked. There is one left which will have to be picked by A. And the player who takes the last matchstick loses, so A will lose. So with 7 matchsticks, B can ensure that A loses. And that becomes the answer. Basic application of a concept of games, moderate question, because such questions would have been done earlier. About 2 minutes to solve the question. Anil wrote down all the possible 3-digit numbers with distinct digits on the blackboard. Of these numbers, Viswas erased all the numbers whose first and last digits were either both even or both odd. How many numbers were left on the board? the number of numbers that Anil wrote all possible three distinct digits. The first digit has 9 options. One digit is used. The second digit has 9 options. Of the one that is remaining that cannot be used, and the last digit has 8 options. In this case, we will get all the numbers, three-digit numbers with distinct digits. This will come out to 9 nines are 72. Okay, 9 nines are 81 into 8, 648. All the possible three-digit now distinct digits. Of these Biswas series, all numbers whose first and last were either both even or both odd. Now, if we look at Biswas's numbers that he's erased, we are looking at the case where both the numbers are odd, first and last digit. So here there are 5 cases, 5 odd numbers, 1, 3, 5, 7, 9. One is used here, so one of the remaining 4 can be used here. 2 numbers have been used out of 10, so 8 possibilities for the middle digit. So 8, 5 4s are 20, 60. 5 4s are 20, 2 8s are 16. Odd and odd. If you look at even and even numbers, one of 2, 4, 6, 8 can come here. The remaining number from 0 to 4, 6, 8 can come here, both even, and therefore 2 numbers used. One of the 8 numbers digits can come in the middle. So this will be 4 4s are 16. 16 into 8 will be 64 into 2, 128. And therefore, Biswas has removed 288 numbers out of 648. So the remaining numbers will be 648 minus 288. So 360 numbers should remain on the board. Again, I think not a very difficult question. About 2.5 minutes should be good enough to attempt this question. So if I look at the oral test now again, the overall level of difficulty for this test would be moderate, where we were trying to get 5 to 6 questions netted correct in about 25 minutes of attempt. My 5 questions would be 3, 4, 6, 8, 10. Which are these questions? Not doing this in the examination. Again, unless I know exactly the formula for 44 and that 44 and 00 are the only 2 cases, this could be very, very lengthy in the examination. Would have done this simple counting. Would have done this as well because calculation was not very high. Again, chance of getting confused, might not have done this in the exam. Would do this every time in the examination, only 2 APs, we have to find the sum. This could be confusing. Would have done this in the examination because, again, it is not very difficult to see that 135 and 115 are the 2 cases, and we're getting the values easily. Since I've done this, I would have attempted this in the examination because I've done similar questions, but you can take a call on this question. This question also could have been done because basic concept of numbers and combination is used. So 3, 4, 6, 8. The 5th question could be 9 or 10, depending on what we find easy. So these would be my 5 questions for this test.